Once again, we're going to take time to prove an important geometric theorem, and that is same-side interior angles theorem. Proving theorems in geometry is an important skill, an important thing for all students to understand. Not just being able to do the proofs, but it helps you to fully understand the way that all these pieces fit together. As you can see there, it's also considered a very important part of any curriculum, as the Common Core Standard talks about the importance of proving theorems in geometry. Also, I do want to have a disclaimer to say that this theorem, the way I'm going to prove this theorem is in a somewhat basic way, not very detailed. We're just more trying to get a big picture. So your teacher, or if you're a teacher, you yourself might expect more rigor than I'm going to show. Okay, so to do this, we've got to state our theorem first, which is if two parallel lines are cut by a transversal, then same side interior angles are supplementary. And again, this is a very important theorem and used a lot in proving things about parallelograms and other type of settings, and so it's one we want to know well. Remember that your hypothesis or your if statement of a conditional is where you get your given. In this case, it's that two lines are parallel, so we've got to name those two parallel lines as L and M. So my first step in this proof is just stating, for the record, that L is parallel to M. And your reason for that is that's given. That's part of your assumption about this picture, that L is parallel to M. Before I can move on, I'm going to need to use some numbers to represent some angles here. And so I'm going to say that 1 and 2 are my same side interior angles. And then I'm going to go ahead and put a 3 right there to help me along, and that's what I'm going to need for this proof. There's a couple different ways I could have gone about this proof, but I'm going to use the corresponding angles postulate to do it. So I'm going to start and talk about some of the things that are apparent from this. First, using that corresponding angles postulate, we've got angle 2 is congruent to angle 3. Remember, in parallel lines, corresponding angles are two angles that are in the same place when you look at these vertices here. So in this case, 2 and 3. And so if they are parallel, then what we know about corresponding angles is that they're congruent. So we can claim they're congruent just by saying the corresponding, what I have my students is just go ahead and state it. Corresponding angles are congruent. We know that to be the case. It's something we've accepted as a postulate, so we can just state corresponding angles are congruent. Your teacher may require you to say if lines are parallel, then the corresponding angles are congruent. Or they may have you just say the corresponding angles postulate. Whatever's fine. I like the corresponding angles are congruent because it reminds us what we're doing. The other one we want to look at is angle 1 and angle 3 are supplementary. Okay, angle 1 and angle 3 are supplementary because linear pairs are supplementary. And angle 1 and angle 3 are a linear pair. Now, my goal is to show that angle 1 and 2 are congruent, so I need to somehow combine these two statements to do that. Well, to do that, I'm going to have to use some algebra. And so measure of angle 2 equals measure of angle 3. If I do algebra, remember you got to do the measure of the angles. That's just by definition of congruent angles, which means that you know that if you've got two congruent angles, then the measures of those two angles are the same. I can also then state by definition of supplementary that measure of angle 1 plus the measure of angle 3 equals 180. Right? That's the definition of supplementary angles. Now all of that is good because our goal is to show 1 and 2 are supplementary. So to show that they're supplementary, I need to get rid of that 3. So I can do that by substituting in for 3 measure of angle 2. So my next statement by substitution can be measure of angle 1 plus measure of angle 2 equals 180 because I know that angle 3 and angle 2 are the same. And the reason for that should have been step number 6, is just substitution, a very powerful thing in these proofs. Now I've got what I wanted. I wanted measure of angle 1 plus measure of angle 2 to equal 180, so I just claim what I was going to claim, which is angle 1 and angle 2 are supplementary. And we know they're supplementary because our definition of supplementary angles says so. And so we write down just definition of supplementary angles, and we are done with this proof. And we are confident now that when we have parallel lines, same side interior angles are supplementary. There are other ways you could have done this. You could have used the alternate interior angle theorem if it's already been proven for you. And there are a few other ways that you could have gotten there as well.